This Regents chemistry video, we're going to talk about electrolytes and what they are in terms of solutions and what they mean. So an electrolyte is a substance that when you dissolve it into solution produces ions that conduct electricity. So this is the important part here, that it produces ions that's going to cause the solution to be electrically conductive. So these electrolytes, they're going to dissociate into ions, so break up into ions. So something like an ionic compound, if we say maybe calcium chloride, CaCl2, this will break up into one calcium plus 2 ion and 2 chloride ions. So this, we would get a total of 3 ions out of this calcium chloride solution. So this would be a decent electrolyte because it's going to break up and give us a bunch of ions. So the difference between a strong electrolyte and a weak electrolyte is that a strong electrolyte is something that's going to dissociate very well. It's going to break up into ions really well. So this calcium chloride is really going to break up into ions, and we're not going to have a lot of unbroken up calcium chloride. It really is going to dissolve well and dissociate well into ions. So a weak electrolyte would be something that doesn't dissociate well, that only produces a few ions in solution and not really dissolving or dissociating all the way. So that's how you can tell between a strong and a weak electrolyte, is something that's going to break up really well into ions, that would be a strong electrolyte, and something that's not would be a weak electrolyte. So a non-electrolyte is something that doesn't produce ions in solution at all, and this will not conduct electricity. So the higher the concentration of ions, the better the substance conducts electricity. So these non-electrolytes, they're not going to conduct electricity at all because they're not breaking up into ions. And between the strong and the weak electrolytes, well, the strong electrolytes would conduct electricity better because they're breaking up into ions more so than these weak electrolytes are. So again, important thing to know here, the higher the concentration, the better the conductivity. So if we have more ions in the solution, more of these electrolyte type ions, then that's going to make for a more conductive solution. And if we have a weak electrolyte, or even worse, a non-electrolyte, that's not going to make a conductive solution. So we got a couple of Regents questions here related to electrolytes. So which substance is an electrolyte? We said electrolytes are things that are going to break up into ions and conduct electricity. So what we want to do is just think which of these could kind of easily break up into ions. So looking at all these, we have kind of this covalent compound here with carbon chloride. We have an organic compound here with C2H6. We'll talk about these organic compounds later, but this would be ethane. And we have water here, which isn't really very ionic or very likely to break up into ions. It kind of just likes to be water. We'll talk about kind of acid-base stuff where that gets a little fuzzy, but for right now, the HCl is the one thing here that we could really see as dissolving into H plus and Cl minus, kind of dissociating into these ions. This is a ionic or almost ionic compound where we have a really uneven distribution of these electrons here between the chlorine and the hydrogen. So this is going to split up pretty well into ions. So the answer here would be HCl. So again, electrolyte is just something that is going to break up into ions and therefore conduct electricity in solution. So which of these compounds is an electrolyte down here? Well, we've got some of the same choices. CCl4, that's obviously not going to be a very good electrolyte. We've got an organic alcohol here, which again we'll talk more about organic stuff later, but this is not going to be ionic. And then we've got sugar here, which is not going to be ionic either. So basically, these organic compounds not usually going to be electrolytes. There's one exception there, and that is with an acid, but again, these organic compounds we'll talk about later in the game. So here, this calcium hydroxide, and this is a base. We haven't really done acid-base stuff yet, but this is going to make calcium plus 2 and 2 OH minus ions. So we've got 2 hydroxide ions here and 1 calcium ion. So this is going to be a compound that is a good electrolyte because it's going to break up into those ions really well. So if you can kind of see a compound and see how it might be able to break up, like here we have calcium and hydroxide, if it might be able to break up into ions well, then that's probably going to be an electrolyte. If we have something organic like this, or something covalent like this, those are far less likely to dissolve into ions well, and therefore wouldn't be electrolytes because they're not going to conduct electricity in that solution. Alright, a couple of final questions here. So we have a test result to determine if KCl is an electrolyte. So what we said about electrolytes was that they're going to conduct electricity in solution, so that's the key. So we could take the pH. pH is an acid-base measurement. That's really not going to come into play here. But what we would want to know about is the electrical conductivity of KCl, because that's what an electrolyte is something that conducts electricity well. So if we're trying to see if KCl is an electrolyte, we see is it electrically conductive. But the key is here, we want to know if it's conductive in solution, because like we said with the NaCl example, which this is going to be very similar, is we have Na plus and Cl minus, it breaks up into ions in solution, and that's what enables the electrical conductivity. So the substance by itself, NaCl as a solid, is not electrically conductive, but in solution it is. So KCl as a solid is unlikely to be electrically conductive, but in solution, when it dissolves into those ions, that's going to tell us that it's an electrolyte, because again, an electrolyte is something that dissolves into ions and then conducts electricity in solution. So it's the solution, this aqueous phase, that we care about here. So last one here, which would be a better conductor of electricity, a 2 molar solution of NaCl or a 5 molar solution of NaCl? So this goes back to the first slide where we said that basically the higher the concentration of ions, the more electrically conductive something is going to be. So we've talked about molarity. This 5 molar would be a greater concentration than the 2 molar. Well, so the 2 would be less than the 5, or however you want to think of that. The 5 molar, we have a higher concentration of NaCl, so that's going to give us a higher concentration of sodium and chloride ions. So again, the higher the concentration of ions, the greater the electrical conductivity would be. So the answer would be this 5 molar solution. Alright, so I hope you got a good intro on electrolytes here, and see you in the next video. Thank you.